In this first tutorial of topology, I would like to talk about two interesting problems that we kind of posed in our lecture 0.4 actually. And the two problems were, one of the problem was ring problem. Okay, I'll introduce that problem again and its obviously solution, and the holy donut problem actually. Okay, so holy donut problem. I would like to say at the outside that both of these problems are taken from a beautiful book by Edward G. Berger. So Edward Berger and Michael Starbird. Okay, the name of the book is The Heart of Mathematics actually. Heart of Mathematics. So this book is basically a really interesting book actually, in which both authors kind of propose and focus on talking about the strategies to learn effective thinking. So how to learn to think effectively through mathematics actually. So it's a book on effective thinking. So let's move towards the first problem. So the first problem is really what do you call the ring problem. So let me give you the description of it and then talk about it. So the first problem says that imagine you have this, I don't know, let's call it paper napkin with the two holes and a ring is passing through it. Okay. Can you do some continuous transformations or, maybe some stretching or extending, shrinking, or something to this paper napkin with the two holes in such a way that a ring kind of passes only through the one of the hole, not the both of the holes actually. Okay. Now this seemed like really very odd thing actually in our universe actually. So in our universe, it seems like something very odd. How can something that is passing through two holes can be put into the one hole actually? But imagine that these days we are talking about what do you call a very strange universe actually, the topological universe, in which everything is made up of extremely flexible materials. So assume that this blue paper napkin is made up of, say, extremely flexible maybe elastic, okay, material, okay, maybe rubber or something like that. And then the question is that, in other words, that you can, to this blue napkin, you can, stretch it, you can shrink it, okay, you can, extend it, contract it, fold it, do whatever, okay, but without kind of breaking it. So it's like a breaking is not allowed, or the gluing is not allowed, okay. So it's like doing only the continuous transformations. So it's like doing some continuous transformations of, say, stretching, shrinking, or folding. Can you turn this picture in which the the ring is passing through the two holes? Can you turn it, or can you put the ring into the one hole actually? And you are allowed to do these things, these operations. Okay. So, I mean, if you haven't thought about this problem, you can pause the video and think a moment about it, that whether it is possible to do it or not. So let's move to the solution of it actually. So the solution is really interesting actually. So let's start with, for example, this first picture. Okay, so what we can do, so the first step that we can do is really that, okay, let's take this hole, okay, like this hole. So I'm kind of, putting my finger inside this hole actually and kind of extending it, making it bigger. Okay, so it's like, okay, let's make this hole a bit bigger actually. Okay, so you can also say that, okay, I've kind of decreased the distance between these two, sides actually. So I made this one hole bigger actually, and here in the third step, I kind of made it, even more bigger actually. Okay, and I made this strip more thinner, and then I holded, for example, this strip from here, and I'm kind of rolling it over, onto the onto the ring actually in such a way. So I'm rolling it. So like, okay, rolling it a bit more. Okay, so this red side is really the back side of the napkin actually. Okay, rolling it more and kind of rolled it over, and eventually I'm gonna get what do you call such a picture actually. And you can see that you're already, your ring is in one hole. The only thing that you have to do is to basically that, okay, can you turn this picture into our required picture? So what I can do, I can invert, you know, um, the sides of this part, and it would like invert and invert it more, and then it will, kind of turn it into such kind of an object actually. Okay, and then, really reduce the size of the hole. And eventually what we saw, that we started from here, and I did only, shrinkings and, extensions, okay, and foldings, and I turned my, my picture, like the ring that was passing through two holes, into the picture into the ring where the passing through the one hole actually. Okay, so maybe this is not possible in our, our kind of universe, but it is possible in the strange topological universe actually. And I think it is also possible kind of physically as well actually. I mean, if you take, for example, a stretchable napkin and put a ring around it, I think you can perform all these operations physically too. Okay, so this was really the ring problem, and this is really the solution to the ring problem. Okay, and that's why we say that really the topology, this rubber sheet geometry, is really counterintuitive. Okay, let's now move towards the second problem actually. So the second problem, the problem 2, is really the problem, so-called problem of holy donut. Okay, let's give it a name. Problem, the holy donut problem. Holy donut. So you may assume that, okay, imagine that you have this donut, but like these both sides of the donuts, okay, the both holes of the donut are entangled with each other. Okay. The question is, can you make it into, or turn it into the standard donut actually, the standard donut. Okay, and assumptions are same, that okay, like both of these objects are made up of extremely flexible material, elastic material, rubber material, okay, that you can extend or stretch or fold as much as you like actually. Okay, so if you want to think about, so like this really seems a counterintuitive problem actually, that how can these things, or these holes which are entangled with each other, can be unentangled without really breaking, one of them. But you can see actually that this is, this is really possible. If you want to give a thinking to it, you may pause the video and think about it. Okay, now let's move towards the solution of the holy donut problem. So here's a solution to the problem. Okay, so let's just start with, for example, this first picture. okay, which is like entangled, these entangled holes. Okay, so what I'm doing is that basically I'm taking this part, okay, of this strip actually, and extending it. Okay, so like making it thicker, making it fatter actually. And then in the second step, I'm taking these two sides and making them fatter. Okay, and in the third step, I am making all these three sides even more fatter actually. So I can make them fatter and fatter. And then in the fourth step or fifth step, basically I have made them fat in such a way that there is no space between them actually. Okay, so it's like I made this guy even more fatter. So it's like I made kind of an extension actually, and it turned it into such a picture. Okay, so you can see that these both of the handles, you can say that this looks like a dumbbell that you take actually, okay, in your gym. But these handles of these dumbbells are really entangled with each other. Okay, but everything here is flexible. Okay, you can move it. You're not allowed to break it. You are not allowed to kind of glue and create anything new out of it. Rest, you can move anything you like actually. So from the fifth to the sixth step is that I started moving one of the handles. So one of the handle is attached at some place. I kind of holded it and I'm attaching it onto, for example, a new place. Okay, and then I'm taking this handle and holding it, are taking it at a at a place at the back actually. Okay, so in this manner I untangled what you call both of the handles actually. And then what we can do, for example, is that okay, I just in this from this step to this step, what I just did, I just really the both of the handles which were sideways, I have kind of put them in front actually. Okay, and then in the next step, the handles that were adjacent to each other, I kind of moved them, and I put one handle on the right side, another handle on the left side actually. And then finally, I just took this middle part of this picture and kind of shrunk it actually. Okay, and made it a bit thinner actually. And then I got like, okay, like I turned this part into what do you call such a part actually. Okay, and and you get what you call your required picture actually. So in other words, in order to transform this picture into this, you can observe actually from here that you have only used stretching, shrinking, moving, the parts of object of, folding, I've applied all of these operations in order to turn this picture, this first entangled picture into the, what do you call the two-hole donut actually. Okay, and nowhere I have used what do you call any breaking operation or the gluing operation actually. Okay, the discontinuous operations. Okay, so as a result, I can say that both of these pictures, like in fact, each one of these pictures, in like this picture and this donut are topologically equivalent actually. Okay, because you can apply some kind of continuous transformation and turn it into the donut. And similarly, in this problem, like these both pictures, in other words, the ring that is passing from two hole is topologically equivalent to the ring that is passing through what we call one hole actually.